Hello everyone, welcome to Testport MBA Prep. So this is the part 2 of Inequalities. If you haven't yet watched the part 1 of Inequalities, kindly watch that and come back to this. And if you haven't subscribed our YouTube channel yet, do subscribe it, and in the description box I have given you the Telegram joining link, so you can also join our Telegram group. So the agenda of this session is we will look into AMGM inequality, the arithmetic mean and the geometric mean, and then we will know how to solve, right? We will deal with solving polynomial inequalities, and then we will move on to the rational inequalities, and we will solve different models, different problems. So this is a very important session for all the CAT aspirants and ZAT aspirants. Not so important for a TISNET or CMAT, but this is really important for CAT and ZAT. So what is AMGM inequality? The inequality talks about the arithmetic mean which is greater than or equal to geometric mean. If we further extend this, then this geometric mean will also be equal to greater than or equal to harmonic mean, right? And this is applied for only positive real numbers. Please remember this. This property is applied for only positive real numbers. Well, how can we calculate arithmetic mean? Let us say we have three numbers A, B and C. How can we calculate arithmetic mean for A, B and C? Just A plus B plus C by 3, right? It's an average. So how can we calculate geometric mean? A into B into C whole power 1 by 3. So as there are 3 digits, it is 1 by 3. How can we calculate harmonic mean? Well, it is the reciprocal. So 3, how many digits are there? 3 are there, right? So 3 by 1 by A plus 1 by B plus 1 by C. This is how we calculate AMGM and harmonic mean HM for 3 digits. So AM is greater than or equal to GM, GM is greater than or equal to HM. So this property is applied to any number, n number of any number. So I have just taken 3 digits to give you an example. And the next important thing here to notice, how can we and when can we apply AM GM or GM HM or HM AM, right? When can we apply? If we are asked to find out, right, or if we find out any sum or product, right, sum and product, combination sum and product, then we must apply arithmetic mean and geometric mean, because arithmetic mean indicates the sum of the digits, geometric mean indicates the product. So when can we apply harmonic mean? If there is any reciprocal, right? If there is any inverse, then we can apply harmonic mean. So if geometric mean, if the product and the reciprocal of it are given, right, then we can use the combination geometric mean and harmonic mean. Or if there is any combination like addition and the reciprocal, then we can use arithmetic mean and harmonic mean. So it depends on the question that you are solving. So we shall look into various models so that you will have a better clarity on how to solve and how to approach. So we shall look into this problem. Find the minimum value of 4 tan theta plus 9 cot theta where tan theta, cot theta are positive real values. So just pause the video and try to think which property to apply. So here we have 4 tan theta, 9 cot theta. So as we know, the arithmetic mean is greater than or equal to geometric mean. So what is the arithmetic mean here? Arithmetic mean of 4 tan theta and 9 cot theta. So 4 tan theta plus 9 cot theta by 2. This will be greater than or equal to the geometric mean. What is geometric mean? 4 tan theta into 9 cot theta whole power. So we have two values here, so 1 by 2. So tan theta and cot theta get cancelled as cot theta is 1 by tan theta. So 4 tan theta plus 9 cot theta by 2 will be greater than or equal to 4 into 9. So tan and cot get cancelled. 4 into 9, this is 36. 36 power 1 by 2. So this will be equal to 6. And if we bring this 2 to the other side, it will be 12. So 6 into 2. So 4 tan theta plus 9 cot theta, this will be greater than or equal to 12. So 12 is the minimum value of 4 tan theta and 9 cot theta. 4 tan theta plus 9 cot theta. So let us look into this. Which is greater between 1 and 1 by 1001 plus 1 by 1002 and so on till 1 by 3001. So which one is greater? Now if we observe, this is the reciprocal of 1001 and this is the reciprocal of 1002. So we must use harmonic mean, right? So if we consider these numbers 1001, 1002, 1003, 1004, so on till 3001, right? If we observe these numbers, what is the harmonic mean? Okay, before calculating harmonic mean, let us calculate arithmetic mean. So arithmetic mean is just the average. So the first digit plus the first term and last term by 2. This will be greater than or equal to harmonic mean. Harmonic mean is inverse of it. So from 1001 to 3001, how many digits are there? There are 2000 plus, from 1001 to 3001 there will be 2000 plus 1. So it will be 2001 digits. So 2001 by the reciprocal of this 1 by 1001 plus 1 by 1002, so on till 1 by 3001. But if we observe here, we are asked to find out the greater value. So there is no need of this equality sign. So we can ignore that equality sign. So this will be 4002 divided by 2. So this can be 2001, right? So 2001 will be greater than 2001 by this, and 2001 and this and this get cancelled, and we will be left with 1 is greater than 1 by. So we are left with this. So the second value, which is 1 by 1001 plus 1 by 1002, so on till 1 by 3001 is greater than 1. So between 1 and this value, this is greater, right? We shall move on to the next question. So find the least possible value of 1 by a plus 1 by b plus 1 by c plus 1 by d among the following options if a plus b plus c plus d is equal to 12 and all these are positive numbers. So this is the sum, this is the inverse. So we can use arithmetic mean and harmonic mean. So arithmetic mean will be greater than or equal to harmonic mean. So what is the arithmetic mean for a, b, c and d? It is a plus b plus c plus d by 4. This is greater than or equal to harmonic mean 4 by 1 by a plus 1 by b plus 1 by c plus 1 by d. We know the value of the numerator a plus b plus c plus d is equal to 12. So 12 by 4 is greater than or equal to 4 by. If we bring this 4 to the other side and if we simplify, then we will be left with 1 by a plus 1 by b plus 1 by c plus 1 by d will be greater than or equal to 4 by 3. So what is the least possible value here? Least possible value for this expression is 4 by 3. Option A is the correct answer. Let's move to the next question, which is if a power 7 b square into c cube into d power 5 is equal to 512, find the minimum value of a power 7 plus 2b square plus 2c cube plus 2d power 5 when a, b, c and d are positive real numbers. So if you observe, this is geometric mean because a power 7 into b square, right? And this is the arithmetic mean as summation is involved. So arithmetic mean is greater than or equal to geometric mean, right? Geometric mean. So arithmetic mean, how can we calculate the arithmetic mean? So a power 7 plus 2b square plus 2c cube plus 2d power 5 divided by 4, this will be equal, greater than or equal to, what is the geometric mean here? A power 7 into 2b into 2b square into 2c power cube into 2d power 5 whole power 1 by 4. Now this 2 into 2 into 2, this will be equal to 8. So 8 into this will be equal to a power 7 into b square into c cube into d power 5 whole power 1 by 4. And we know the value of this, right, which is 512. So we can substitute this here, and if we bring this denominator to the other side, it will be 4 into this value, and we can change 8 into 512. So 8 into 512 can be expressed as 8 power 4. So 512 is 8 cube, and so this will be 8 power 4. Hence we can make it as, this is 8 power 4 whole power 1 by 4. So this and this get cancelled, and this will be greater than or equal to 4 into 8. So this will be greater than or equal to 32. So the minimum possible value of this is 32. So I hope you are clear with this AMGM inequality application. So whatever the problem, you have to just identify the expressions, whether it is product or sum or inverse, and according to that we will take whether we must apply the arithmetic mean or geometric mean or the harmonic mean. If we consider this one, so if f of x is equal to 24 x square plus 6 by x, find the minimum value of f of x where x is a positive real number. So what is the given expression f of x? So this is equal to 24 x square plus 6 by x. So we can modify this and we can express this one as 24 x square plus 6x can be 6 by x can be written as 3 by x plus 3 by x. This is the sum, 24x square plus 3 by x plus 3 by x, this is the sum. And if we want to find the product, we can make it as 24x square into 3 by x into 3 by x. So these two get cancelled, and this will be 216. So here this a, b and c, this is equal to 216. This is a constant, right? Constant. So product is 216, sum is minimum. So 216 is the product. So in order to find out the minimum sum, these three values, right, these three digits must be as close as possible, or they can also be equal. If they are equal, it is perfect. If they are not equal, we shall make it as close as possible. But if we observe 6 into 6 into 6, this is equal to 216, and 6 is equal for all three cases. Hence 6 plus 6 plus 6, this is equal to 18. This is the minimum value of. So till now we have discussed how to apply the arithmetic mean, geometric mean, harmonic mean inequalities. Now we shall look into how to solve the polynomial inequalities. The first question here is, find the largest integral value of x for which the expression is less than 0. So the inequality is given here. So if we observe, we want to find the largest integral value of x. So if we observe here, x minus 2 whole square and x minus 4 whole square, these two cannot be less than 0, right? The only values which can be less than 0 are x plus 2, x minus 1 and x minus 3. These three can be less than 0. And if these three are less than 0, what are the roots? Roots are minus 2, 1, comma 3. Let us plot this on a number line. So minus 2 will be here, 1 will be here, and 3 will be here. If we observe the coefficient of x power 5, right, coefficient of x power 5 is positive. So we shall start with positive sign from the rightmost side. So positive and negative. But what do we want here? We want the largest integral value, and the sign is less than. So consider only the negative part, the negative area. In this negative area, that is from 1 to 3, what is the largest integral value? It is 2. And from this area, this negative area, the largest value is minus 3. But if we substitute 2 here, 2 in this case, 2 minus 2, this will be equal to 0, and the entire expression will be equal to 0. And if it is equal to 0, then this doesn't satisfy this condition, which is less than 0. Hence, minus 3 is our answer. Right? Let us move on to the next question. So the smallest integer n such that the expression is greater than 0 is. So this is this appeared in CAT 2018 slot 2. So if you observe this expression, the roots can be taken as a comma b comma c, right? If we assume these three as roots, then the sum of these roots a plus b plus c must be equal to 11, right? 11. And the product of these three roots a b c must be equal to 28. And what must be the product of two roots? That is ab plus bc plus ca, right? This will be equal to 32. Now sum must be 11 and product must be 28. What can be the possible case? 11 and 28. If we take 7 plus 2 plus 2, right? 7 plus 2 plus 2. This will be 11. Sum is 11, whereas the product is 7 into 2, 4. It is 14. 14 into 2. This is 28. So this is a possible value set. Okay. So the expression can be n minus 7. So these three are roots. So we can rewrite the expression as n minus 7 into n minus 2 into n minus 2. This will be greater than 0. If we plot this on a number line, then it will be 2 comma 7. So one more root is also 2, right? So it will be in this place itself. And the coefficient of n cube is positive. So let us start with positive, negative, and please remember, had this been one more root, one different root other than 2 itself, then it would have been plus here, because the sign changes alternatively. Because the two roots are same here, right? Two roots are same here, so it will be minus in this case. Important point. So plus, minus, and minus. Here we are asked to find out the greater than 0. So consider only the positive area, positive part. So the smallest integer n, we are asked to find out the smallest integer n. So apart from 7, after 7, what is the smallest integer? Smallest possible integer, it is 8. So 8 is our answer. Let us move on to the next question. Okay, so we will now solve the rational inequalities. How can we calculate the range of the inequalities? So first question is, so solve for x in x square minus 5x plus 6 by x plus 2 into 4x minus 1 is greater than 0. Now, we do not know the denominator is positive or negative, so we cannot take this to the other side. What we shall do is we shall multiply the denominator, this value, with the numerator and denominator, right? So let us see how. X square minus 5x plus 6 by x plus 2 into 4x minus 1. So we shall multiply this with numerator as well as the denominator. 4x minus 1 by x plus 2 into 4x minus 1. So this will be greater than 0. Now we can be sure that the denominator is a perfect square, right? Hence it is a perfect square. We can simply multiply the same denominator here and the same denominator on the right hand side as well, so that this denominator and this one get cancelled, and 0 into denominator, 0 into anything is 0. So if we solve the numerator, this part, we can say that the sum must be 5 and the product must be 6, right? Sum must be 5 and product must be 6. So it can be x minus 3 into x minus 2 into x plus 2 into 4x minus 1, right? So this will be greater than 0. What are the roots here? Roots are 3, 2, minus 2 and 1 by 4. If we plot this on a number line, what do we get? We get minus 2 is here and 1 by 4 is here, 2 and 3 will be here, right? X power 4 coefficient is positive, so we can start with positive sign. This is negative, this is positive, this is negative, and this is positive. We are asked to find out the greater than 0, so consider only the positive area, this one and this one. So what is the range? Range of this positive area is, range of this expression is minus infinity comma minus 2 union of 1 by 4 comma 2 union 3 comma plus infinity, right? So this is the range of this expression. So the next question is, solve for x when 2x plus 7 by x minus 4 is greater than or equal to 3. So 2x, okay, if we bring this, bring 3 to the left hand side, we'll get 2x plus 7 by x minus 4 minus 3. This is greater than or equal to 0. If we take LCM, what do we get? We get 2x plus 7 minus 3x plus 12. This by x minus 4, this will be greater than or equal to 0. Now if we further simplify, we will get minus x plus 19 by x minus 4 will be greater than or equal to 0. And at this moment, if we change the sign of x, right, if we make this x minus 19, the sign, the inequality sign swaps over. Let us see how. If we change the sign of x and make it x minus 19 by x minus 4, this won't be greater than or equal to 0 now. This will be less than or equal to 0 because we are changing the sign. Okay, we do not know whether the denominator is positive or negative. In order to ignore the denominator, if it is positive, we can ignore it. If it is negative, we shouldn't ignore. So what shall we do is, we shall multiply this denominator with the numerator as well as the denominator. Then what do we get? X minus 4 into x minus 90. This is same. We applied this in previous questions as well. So x minus 4 into x minus 4, this will be less than or equal to 0, and we can be sure that denominator is a square, perfect square, hence it is always positive. So we shall consider the numerator x minus 4, the roots are 4 and minus 19 is plus 19, right? If we plot this 4 and 19, right, 4 and 19, the coefficient of x square is always positive, so we shall take this positive, negative and positive. It is less than or equal to, so less than or equal to, so consider only this, the negative part, 4 and 19. So the range is 4 comma 19, right? So why I included 19 and excluded 4? Because if we include 4, then and if we substitute here, then what do we get? 4 minus 4 is equal to 0, which is undefined. X by 19 by 0 is undefined. Whereas if we substitute 19 in first case, it will be 0, and it also satisfies the equation, right? It satisfies the equation. That is why we should ignore 4, we shouldn't include 4, and we should include 19. Let us move on to the next question. So the next question is, what is the largest positive integer n such that the expression below is also a positive integer? What is the expression? It is n square plus 7n plus 12 by n square minus n minus 12. So this appeared in CAT 2019 slot 2. If we solve the numerator, the sum must be 7, product must be 12. So the only case that satisfies is n plus 3 into n plus 4 by, if we consider the denominator and solve it, we will get as n minus 4 into n plus 3, and this one and this one get cancelled, and we are left with n plus 4 and n minus 4. So n plus 4 and n minus 4, so the both the numerator and denominator being, if we have n, it will be a problem for us. So if we eliminate n in either numerator or denominator, it would be great. So n plus, what we will do is we shall subtract 4 and add 4. So what will happen now? Now this 4 and 4 get added, right? And n minus 4 comes here. So n minus 4 by n minus 4. This 4 and 4 get added. So this will be plus 8 by n minus 4. Now these two get cancelled. We are left with n only in the denominator, right? So 8 by n minus 4. N minus 4 is a factor of 8, right? Must be a factor of 8, and it's a factor of 8. So if n minus 4 is a factor of 8 and we are asked to find the largest possible positive integer. So if we want to maximize the n value, right? If we want to maximize the n value, we must maximize this value, right? This value factor, right? So what can be the maximum possible factor of 8? It is 8. 8 is the maximum possible factor of 8. So 8 plus 4, this is equal to 12. 12 is the answer. It is the largest positive integer n for this expression. Let us move on to the next question. So the next question is the smallest integer n for which 4 power n is greater than 17 power 19 is closest to. Okay. So it's closest to, this appeared in 2018 CAT slot 2. So if we observe this, 4 power n is greater than 17 power 19, right? So can we make the base, right, this base which is 4, can we express 4 power n in terms of 17 power something? Can we make them equal? The base is equal? No, we cannot make, but we can make the base as close as possible to 17. So how can we make it as close as possible? We can express 4 power n as 16 power n by 2. These two are same. 4 power n is as equal as 16 power n by 2. This is equal to 17 power 19. Now the bases are somewhat closer. Now if 4 power n must be greater than 17 power 19, then this power must be greater than this power. Unless this is greater, this won't be greater. So n by 2 must be greater than 19. N must be greater than 19 into 2, that is equal to 38. If n is 38, right, then it is closest to 39. Hence 39 is our answer. Let's move on to the next question. Okay, the next question is, for how many integers n will the inequality will be less than or equal to be satisfied? Alright, so this is a theta question which appeared in CAT 2017 slot 2. So if we observe this expression, if we just simplify this, what do we get? n square minus 15n plus 50 and 3 into n, this will be minus 3n plus 6, this will be less than or equal to 0. Now n square minus 18n plus 56 will be less than or equal to 0. Product must be 56 and sum must be 18. Sum must be 18. So 14, okay, we can do like this, 14 4 is a 56, 14 plus 4 is 18. Then n minus 14 into n minus 4, this will be less than or equal to 0. So if we plot this on a number graph, right, on a number graph, so 4 and 14 and n square, the coefficient of n square is positive, so we can take this positive, negative, positive. As this is less than 0, consider the negative area. Alright, consider the negative area. and we are asked to find how many integers are there in this part, in this area, right? How many integers are there, including 4 and 14, including 4 and 14. So how many are there? From 4 to 14 it will be 14 minus the initial one 4 plus 1, this will be 14, 10, and 10 plus 1 is 11. So 11 values, 11 integers satisfy this inequality, right? So this is also one more theta question that appeared in CAT 2017 slot 1. The question is, if A, B, C and D are integers such that the sum is 30, then the minimum possible value of the expression is. So if we have A, B, C and D equal, if all the values are equal, then it would be awesome, because the minimum value will be 0 in that case, as A, B, C and D are equal. 0 square plus 0 square plus 0 square, this is equal to 0. But we cannot make A, B, C and D as equal, because we cannot make 30, we cannot divide 30 in 4 equal parts. So we will try to make A, B, C and D as close as possible to find the minimum possible value. So 30 by number of digits, that is 4, is equal to 7.5, right? 7.5, and we can take 7 and 8, because 7.5 lies between 7 and 8, right? We can take 7 and 8. We can assign 7 to 2 values, and we can assign 8 to 2 values, any 2 values, and we have to make sure that the assigning results in the minimum possible value, right? If we assume A, B, A, C and A, D, and if we assume A to be 8, right, and B to be 7, right, B to be 7, C to be 7 and D to be 8, what will happen is 8 minus 7, this will be equal to 1. 8 minus 7, this will be equal to 1. 8 minus 8, this will be equal to 0. So A minus B is 1, right? A minus B is 1. So 1 square plus A minus C. What is A minus C? It is 1. A minus D, A minus D, 8 minus 8, this is equal to 0. So 1 square plus 1 square plus 0 square, this will be equal to 2. So 2 is the minimum possible value. You can also try it for, you can make 8, you can interchange the values, but it won't satisfy the given expression. It won't satisfy the given expression, because here we have square roots, perfect squares, hence all the values must be positive. Even if you get negative values, that will be positive at the end, right? That will be positive. If we try for any other values, 7 and 8, or if we interchange the values, then it won't be 2, it will be more than 2. So the least possible case is 2. Possible value is 2. Let's move on to the next question. See, all these are not a difficult level questions, because CAT doesn't test you a difficult questions as far as inequalities and algebra is concerned, right? So you shouldn't leave arithmetic algebra in CAT, right? First, even if it's modern maths or geometry, first what you will do is, after VARC, after LRDI, when you appear for the third section of CAT, you must scan the entire paper, all the questions of quant first, and pick up the easy level questions, the low hanging fruits. What happens is, when you try to solve with 100% accuracy, when you try to solve all the easy level questions, your confidence gets boosted up, and then you will move on to the moderate level questions. You can avoid the the difficult level questions. Even if you ignore them, that doesn't affect your CAT percentile much. Even if you attempt the easy level questions and the moderate level questions with a high accuracy, at least 90 to 95% accuracy, you'll definitely touch 98 plus percentile in quant. It is applied for any section. The moment you start the section, be it VARC or be it LRDI, you must just scan the paper, dedicate 3 to 4 minutes to just scan the paper, so that you won't miss the easy level questions at the end. Alright, let's move on to the next one. So just pause the video and try to solve by yourself. So what values of x satisfy the expression, the inequality where x is a real number? what is the inequality given here? It is x power 2 by 3 plus x power 1 by 3 is minus 2 is less than or equal to 0. If we assume x power 1 by 3, right, x power 1 by 3 as y, then x power 2 by 3 becomes y square, and substitute if we substitute in this expression, we'll get y square plus y minus 2, this will be less than or equal to 0. And if we solve this, we'll get y plus 2 into y minus 1 will be less than or equal to 0, right? And just plot this on number line. Minus 2, this is 1, right, as the roots are minus 2 and 1. The coefficient of y square is positive, so consider positive, negative, positive, and the sign is less than, so always consider the negative part, minus 2 and 1. So y lies between minus 2 and 1, minus 2 less than or equal to 1, right? So what is minus y, what is y here? Y is x power 1 by 3, right? So minus 2 less than or equal to x power 1 by 3, this is less than or equal to 1. So we assumed x power 1 by 3 as y, so just cube this. If we cube this, it will be minus 8 less than or equal to x is less than or equal to 1, because we are asked to find the value of x, the range of x, right? So we are cubing this, and minus 8 and 1, what is the option? Option 1. Option 1 is the answer. So here in this session we solved various models, different models. All are CAT level questions, ASAT level questions. As far as inequalities are concerned, the first session of inequalities and this session, these two are important, and you can solve any problem in inequality in your CAT or SAT paper, right, by applying these concepts that we have discussed in our 2 sessions. Besides this, you must practice some questions. You can take any standard material, or else you can also practice the topic wise tests that will be uploaded on your portal. So thank you for listening, and thank you for watching. And if you haven't subscribed our channel, do subscribe it, and you can also join our Telegram group. So all the very best. Thank you.